Alright, hi, I'm Lucas. I'm a current Calculus BC student, and I make these tutorials to help me study for my tests. And today's video is going to be about product rule, quotient rule, higher order derivatives, and trigonometric derivatives. Okay, so first let's start off with product rule. Now, for product rule, people like to use f of x times g of x. Now, the issue I have with that is that people always often say it equals f of x, and I find including f of x in this kind of makes it a little bit confusing. So what I'm gonna use terms of u and v. So I'm gonna say I have f of x equals u times v. Now I'm gonna use f prime here. That's just about what I've been taught. I'm used to it. So I'm gonna do u prime times v plus v prime times u. Now you can do this in any order. It doesn't really matter. Um, so usually what I usually just do u prime times v plus u times v prime, so I don't lose track. But this is product rule, right? So let me give you an example. Yeah, let me just erase all of this. Okay, so let me write this. So f of x equals x plus 4 times 3x plus 2. Now let's make this u. Let's make this v. Let's say f of x, well f prime of x, will be u prime v times v prime u. Okay, so let's start. So f prime of x. So let's see. This is u. So what's the derivative of u? It's just going to be 1 times v, which is 3x plus 2. Okay. And then plus v prime. Okay, so derivative of v is going to be 3. And then times u. Oh, sorry. Okay, x plus 4. And then we just simplify this out. We have 3x plus 2, because everything's times 1, plus 3 times x, 3x. 3 times 4 plus 12. Then equals 6x plus 14. Okay, so that's product rule. So this is the work if you want to take a picture of this. So then we're going to move on to quotient rule. Now quotient rule is a little bit harder, but you could get used to it. And I'm actually going to pull up a question for that here as I erase this, because I find it to be a little bit harder. So I kind of want to make it more streamlined. So let's see. So yeah, but first let me explain the rule. So if you have f of x, and I'm gonna people like to use g of x and f of x, but I'm gonna use u and v. So I'll use u, v. So f prime is gonna equal. So you have a long division side. You're always gonna have the bottom one on the bottom but squared. And so there's a rule that my calculus teacher taught me called low d high minus high d low over low low. So low d high minus high d low over low low. Okay, so this basically means that you're gonna have the thing on the bottom times the derivative of the top minus the thing on the top times the derivative of the bottom, all over the bottom squared. And this is quotient rule. It looks kind of complicated, but let me show you here. Let me write it in terms like this. So you're gonna have low v times u prime minus u times v prime. Okay, so let me erase all of this. All right, I'm gonna move this over here. Okay, so because this one I always, whenever I do a problem, I always write it out. So I have a problem of f of x equals x plus, well, not x, x over x squared plus 1. Okay, so this is going to be our v, this is going to be our u. Alright, so let's start out. Giant division. I always do this bottom one first because it's just easy to do. I know, x squared plus 1 squared. Alright, so v, what is v? Alright, so we're going to do x squared plus 1 times the derivative of u, which is just 1. Also, if you don't know how to take derivatives right now, I'd highly recommend watching a video about that, power rule. Okay, then minus u, which is the thing on the top, x, times v prime, which is going to be 2x. And that's going to equal all over x squared plus 1 squared. It's going to be x squared plus 1 minus 2x squared. Now, we can simplify this. It's going to equal, right? Oh, I can't write right there. Okay, it's going to be negative x squared plus 1 over x squared plus 1 squared. Okay, now I'm going to make this a little prettier, but that's your answer there. There we go. Boom. Alright, so this is going to be your answer using quotient rule. And of course, you're going to have more complicated problems than this, but this is kind of like the basis of it. So, alright. So now I'm going to explain higher order derivatives. So let me just clear all this. Alright, so say I have f of x equals, let's say 2x to the power of 4 plus x to the power of 3 plus 3x to the power of 2 plus 8x plus 5. Now if you have f prime of this, you're going to end up with 8x to the power of 3 plus 3x squared plus 6x plus 8, because this turns into a 0. Well, higher order derivatives is just the derivative of the derivative. So if we have f prime prime, right, we're going to take the derivative of this. It's going to be 24x squared plus 6x plus 6. Then if you have f prime prime prime, you're going to end up with 48x plus 6. Then f prime 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 x is going to be equal to 48. Then you have f prime 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 of x. It's going to equal 0. So this is basically higher order derivatives, and it's used in stuff like position, velocity, acceleration, physics. Because the derivative of position is velocity, the derivative of velocity is acceleration, the derivative of acceleration is jerk. So in the end, it'll always equal 0. Like the derivative of everything should always equal 0. Like in a polynomial, should always equal 0. So clear that. Okay, on to trig. Now, of course, I'm the way I'm going to be writing these is I'm going to be writing them as d over dx. Let's start out with the basic ones. Sine. Oh wait, hold on. All right. So sine x equals cosine x. Derivative of dx equals, what's it called? Equals, I don't know why I keep writing the equals here. Of cosine x equals negative sine x. Alright, so these you've probably seen before, but there's 4 more. Alright, So write dx. See, look, keep writing that equal sign. We're gonna do dx tangent x equals secant squared x. Then we're gonna have derivative of dx. So we're gonna have derivative and then cotangent x equals cosecant squared x. Then derivative of secant x is going to equal secant x tan x. And then derivative of, dang. Derivative of, uh, oh yeah, cosecant is going to equal cosecant x times cotangent x. So these are all the basic ones that you need to know. And so yeah, like I said, basic ones that you need to know for trig. Now, let's do a problem here. Alright? So, alright. I'm gonna have here, I'll leave these up just in case you wanna follow along. I'm only gonna do one problem here, make it short and simple. But let's see, I have f of x equals negative x plus tan x. Now we know f prime is gonna be equal to negative 1 plus what's tan? Secant squared. Now you have this. This is going to be equal to, let me think about it for a second. I haven't done trig identities in a little while, but I believe it should be equal to tan squared x. Now, let me let me double check my work here. Let me double check. And yes, that is correct. Tan squared x is what you're going to get because of the trig identity. Secant squared x minus 1 equals tan squared x. Now, if you want to see some problems, well, you can't see the problems, but if you have a textbook by a certain uh, group called, I believe it's Edwards Larson, something Larson Edwards something. There's something called CalcChat, which by Ron Larson. I'm sorry, but it has answers for every odd number question in any textbook by them. So that's also where I'm getting some of these questions. But yeah, that's these trig identities. Now, if you guys want something else, any tips for me, did anything wrong in the video, let me know. But yeah, that's quotient rule, product rule, higher order derivatives, and trig. Alright, bye bye.